All right, Unit 3, Systems of Equations. This is the most difficult chapter in the entire book, and yet the easiest chapter in the entire book. How can it be both, Coach Herman? Well, it can be both because, one, I'm going to teach you to solve systems graphically using Desmos. That's what makes it so easy. The difficult part is I'm going to teach you all of these methods. I'm going to teach you to do it graphically, by substitution, by elimination, and then also do the same thing with linear equalities. The cool thing about linear equalities is there's only one way to solve those, and that's by graphing. Okay? But I'm going to give you notes on all of these today, and I'm going to talk about all the different methods of solving systems of equations, and then we'll go back and figure it out from there. Okay? But I want to give it to you all at one time. So let's start by solving systems graphically. First of all, what is a system? What is a system of equations? Well, it is when you solve two or more equations simultaneously. Big word. What's that simultaneously mean? At the same time. A system of equations is when you solve two or more equations simultaneously at the same time. The first method, there's three methods then to solve systems of equations. The first method is graphing. The second method is called substitution. And the third method is called the elimination method, aka addition method. What's aka stand for? Also known as the addition method. Okay. How many is this already starting to sound familiar to you? I know you did it last year, so hopefully it'll come back to you. Hopefully it'll come back to you. All right. So for starters, let's solve a system graphically. How do we solve a system graphically? Well, we graph all equations and look for the point of intersection. We graph all equations and look for the point of intersection. Now, I'll be honest with you. We're only going to deal with two lines at a time. We're only going to deal with two lines at a time, but a system could essentially have 3 lines or 4 lines or 5. Okay, but the more lines it has, the chances of it actually having a solution diminish. So I'm going to jump down here below and kind of give you what could happen. There's basically 3 things that can happen when we're solving a system of equations. Okay, so here's my 3 coordinate planes. Okay, so let's say I have these 2 lines. Does everybody see where they intersect right there? That point of intersection is the solution to the system. That's what we're looking for. We're looking for the solution or the point of intersection. almost always when we have two lines, they're going to intersect. Who can name for me one time when they will not intersect? Leo? Good. If they're parallel. If I have two lines that are parallel, parallel lines never intersect. So that would be no solution. Now there's one more situation that's very similar to lines being parallel, and that's when you have, I don't know, say this line. Let me go to a different color here. Let's go purple. And this line. Do you see the two different lines there? It's kind of hard to see because they lie directly on top of each other, right? So when it's the same line, there are infinitely many solutions. And when we graph two lines, that's basically what we're going to come up with. One of these three situations. Either the lines are going to intersect and we're going to have a solution. They're going to be parallel and there'll be no solution. Or they'll line right up on top of each other and have infinitely many solutions. Those are the only three things that can happen when we graph two lines. Now, I want to get crazy. Are you guys with me? I know this stuff is like super hard right now, but let's get crazy. Do you realize that in the next section, or really soon, we're going to be graphing these? What is that? It's a parabola, the graph of a quadratic. Could I graph a parabola and a line on the same? Yeah. This particular one would have then this system. This system that I just graphed is a system that has both a quadratic and a linear equation. Is that possible? Absolutely. How many solutions does this one have? 2. I'm going to do one more of those because this looks like so much fun. It is. Could I have this? Could I have this parabola and this linear equation? Could I? Sure. How many solutions does that system have? None. Why not? They never touch. They never intersect. If they don't intersect, there's no solution. Okay, so getting crazy. Now, you're not going to have any of that in this particular chapter, but in this year, we're going to have some of those. Okay, it's totally possible. So how do we solve a system by graphing? We graph them. Look for a point of intersection. Pretty easy, yes? Let me go on and do a couple examples. See if I can find them here using this new squib. Oh, here's some. I'll use these examples. Number 1 and 2 here, these particular examples, the lines are already graphed for you. So who can tell me, looking at number 1, what is the solution to this system? Amanda? Blessing, sorry. 2, 4. There's the point. It's the point 2, 4. Now, what is a solution to a system? Well, here's what it is. A solution to a system is the point that I can actually plug into both of those equations and it works. So watch this. 2 is my x, 4 is my y. Watch what happens when I plug it into this first one. Does 4 equal 3 times 2 minus 2? 3 times 2 is, minus 2 is, yes. Oops. It worked. Now let's try the other one. Does 4 equal negative 1/2 times 2 plus 5? Well, negative 1/2 times 2 is a negative 1. Negative 1 plus 5 is? Oh, wow. That was amazing. I don't know what just happened there. There we go. Yes, it worked there too. And that's what a solution is. The solution is the point, the ordered pair, the coordinates that satisfies both equations. Does that make sense? Hey, wait. Does that make sense?
Yeah.
I know I'm giving you a ton today, but we're just getting started. Yeah, let's go. So looking at number 2, what is my solution to number 2, Brittany? Or Brinley?
Okay. I'd say it's 3 and then 2.5.
Right there. 3 and 2.5. I'll agree with her. That one doesn't look like, that doesn't cross on the lattice point, does it? So here is why. This is an example of why solving systems by graphing is your most inaccurate method when we're doing it by hand. When you're doing it by hand, it's very, very inaccurate. Because what is that point? I don't know. I mean, I can guesstimate it. I can say it's not quite 3, so we'll say about 2.8, and it's not quite -3. We'll say 2.75. But is that exactly it? No, that's not exactly it. So therefore, I can't tell you exactly what it is, so I can't exactly plug it in. And I'm going to have to pause. All right, so back at it. So that's why we need to know the other methods. Now, here's the cool thing. What I'm about to show you next is how to use Desmos. And Desmos is going to give us accurate answers because it's computer generated. Okay? So let's take this next system. Let's look at number 3. I'm going to write these down for my benefit so that I've got something to reference. Number 3 is x equals 3 and y equals -3 x plus 1. Now I'm going to do this problem twice. First time I'm going to do it, I'm just going to do it on the graph here. The x equals 3, boy, that thing looks hinky, doesn't it? Looks weird, but it's not. That's a vertical line through 3. Okay? And if I graph the other one, I start with my initial value, which is 1, and I go down 3, 1, 2, 3, and over 1, down 3, 1, 2, 3, and over 1, down 3, and over 1. So I got this line there, and boom, there is my point of intersection, which happens to be 3, -8. 3, -8, which is a solution to both those equations. You should be able to graph equations that quickly. Yes? You've been doing it for a couple years. Let's look at number 4. Y equals 3x plus 3. What do I start with? Initial value, which is 3. Go up 3, 1, 2, 3, over 1. Up 3, 1, 2, 3, over 1. Or I could have went down 3, left 1, down 3, left 1. Okay? So I've got this lovely straight, super straight line, right? And then the other one, my y-intercept is -2, up 1, over 2, up 1, over 2, or I could have went down 1, left 2, down 1, left 2. What is my point of intersection? -2, -3, and that's my solution. Okay? I want to write that one down as well. Number 4. Somebody read that for me.
Y equals 3x plus 3. Y equals 1/2 x minus 2.
Thank you very much. Because what I want to show you next is what you're allowed to do, and that is to use Desmos. Beautiful, free math. Gotta love that. So we simply open up Desmos, and all we have to do is type in the equation. X equals 3, and y equals -3x plus 1. and then find the point of intersection. There it is. Click on it, and we can see that it is 3, -8.
I didn't know that's the thing.
Understand? Let's do the next one.
No.
Let's go to the next one. Was y equals 3x plus 3 and y equals 1/2 x minus 2. Point of intersection is, come on. Let me click on you. Well, I want to, there we go. -2, -3. Same solutions we just got. Yes? Pretty cool. What happens then, Coach, if they get to be more difficult problems? Like, I don't know, like these. Like number 7. Let's look at number 7. Somebody read that one for me real quick.
2x plus 3y equals 1. 2x plus 3y equals 7.
If we were doing this by hand,
-7.
-7, thank you. If we were doing these by hand, let me start and do number 7 by hand. Okay? In order for me to graph it, I would have to get that in slope-intercept form. So on this first one, I would subtract 2x from both sides, so I'd have 3y equals a -2x plus 1. Yes? Divide by 3. Y equals a -2/3 x plus 1/3. Oh my goodness. That would be really hard or difficult to graph, wouldn't it? And everybody said yes, it would be. The next one, I would do the same thing. Subtract 2x from both sides. I have 3y equals a -2x minus 7. Divide by 3. So y equals a -2/3 x minus.
Pardon the interruption. There is a gray small Chevy SUV license plate number HQB 7186 parked out front with their lights on.
So that would be both of these would be very difficult to graph because they have fractions. It can be done. I just got to really expand my graph and get it into thirds, and that would be difficult to do. But watch this. 2x plus 3y equals 1. And 2x plus 3y equals -7. What do I have? Parallel lines, therefore there is. Do you understand how easy this is with Desmos? Yes? Okay. Now, you're going to be able to use Desmos the whole time. But I want to show you the other two methods as well. What are the other two methods? Well, they are solving systems by substitution and by elimination. Okay? Their name determines what they do. Okay? Their name determines what they do. And let's be honest. When we're talking about systems equations, we would choose which method to do. Like, you could look at a system and realize, hey, this one's set up beautifully to graph both of them. This one's set up beautifully for substitution. This one's set up beautifully for elimination. You'll understand what I mean in a second. I want to go back to one of the questions I've already done. See if I can find it really quick. Here it is, number 3. See, number 3, although we were able to graph it really quickly and easily, this particular system is set up beautifully for substitution. Well, what's substitution, Coach Herman? Substitution is where I substitute the one value into the other equation, because what is x? So why don't I just go, I already know my x is 3. All I need to know still is my y. So why don't I just plug that 3 into the other equation? So y equals negative, so that's equals, negative 3 times 3 plus 1. Or y equals negative 9 plus 1. Or y equals negative 8. Hey, isn't that what we found anyhow? You see, that is called the substitution method. Why? Because we substitute the value of one equation into the other. I'm going to show you another one. This equation here. If we remember, this solution was ugly. And this one will be ugly. But I'm going to show it to you anyhow. See, I can substitute this value, 3x plus 3, in for y. Because it's equal to y. So I can substitute this value in for that y over there. So it looks like this. 3x plus 3 equals 1/2 x minus 2. Are we having fun yet? Oh, yeah. Anybody dislike the fraction? We all like the fraction? How many dislike the fraction? Come on, be honest. Okay, there they go the hands. So how many people want to get rid of the fraction? Good. How do I get rid of the fraction, Mr. Mendoza? Multiply the whole thing by 2. So I now have 6x plus 6 equals x minus 4. Subtract x from both sides. 5x plus 6 equals negative 4. Now what? Subtract 6 from both sides. 5x equals negative 10. Divide by 5. X equals negative 2. Now what do I do with that negative 2? Plug it back in. I'm going to go to the top one so I don't have to deal with a fraction. So the top one is y equals 3 times negative 2 plus 3. Or y equals negative 6 plus 3. Or y equals negative 3. Cool? Questions on the substitution method? Substitution method. Cool. Let's see if I can find an equation that's set up beautifully for elimination. Oh, look at number 5. What's 5 set up for? Substitution. I want to do it again just because this is fun. What do I substitute this 1 in for? Because I want to know. Oh, that was funny. Come on.
Oh.
The y in the other equation. So 4x minus 3 times 1 equals negative 7. 4x minus 3 equals negative 7. Subtract or add 3 to both sides. 4x equals negative 4. X equals negative 1. Well, I already know my y, so what's my solution? Negative 1, 1. And my solution to these systems is always going to be an ordered pair, right? Okay, still looking for one that works for. Number 7's close. I think I can find one better. Here we go. Number 1 is set up beautifully for the elimination method. What is the elimination method? Also known as. You don't have to change this. You just write down that problem. Don't change to the next section. Just write down that problem. Okay? The elimination method is called the elimination method because we want to eliminate one of the variables. It's also known as the addition method because in order to eliminate one of them, we're going to add the two equations together. So, for example, watch what happens. X plus x is, and everybody said 2x. Y minus y cancels, right? You end up with 0y. So it goes away. And then 1 plus 5 is 6. See how we eliminated one of the variables? Blessings like, oh my gosh, what just happened? This is called the elimination method. Now, I can divide by 2, so x equals 3. Now I plug that back into one of the original equations, and I'll go back into the top one. 3 plus y equals 1. Subtract 3 from both sides, so y equals negative 2. So what's my solution? 3, negative 2. And that is the elimination method. Now, I'm going to go ahead and tell you, you're going to need to know all these for geometry. You're going to do all of these in geometry class next year. So if you think, oh, I'll just use Desmos and be done, you'll do fine in here. You'll do fine in Algebra 1, and you'll get your answers right. But if you don't know how to do it without using the calculator, it's going to come back to haunt you. Because guess what you're going to do in Algebra 2? The same thing. This one, if we look at it, what is this method called? The elimination method. If we look at it, if I add those two equations together, will something disappear? What? The x's will disappear. That's what I want. That's why it's called the elimination method. So, boom. So we add them together. My x's cancel. That's beautiful. 3 plus 1 is 4y. 7 plus 5 is divide by 4. Y equals 3. Now what? Plug it in, plug it in. I'll go right there. Negative 2x plus 3 equals 5. Negative 2x equals 2. X equals negative 1. So my solution is negative 1, 3. How many people like the elimination method? Now, how many people like the substitution method? I did too. It was easy. But it depends on what your equations look like. Certain equations lend themselves to certain methods of solving. And that's what you need to figure out. Which one should I graph? Which one should I use substitution? Which one should I use elimination? You'll get to figure that out over the course of this unit. Can I get an amen?
Amen.
Now, I want to go all the way back to this first page because I just showed you everything that you need to know for this chapter. Okay? These three we just talked about. This one is the same thing, but in word problems. And I will tell you that section is the most difficult because you're not given the equations. You have to come up with the equations. And that's a skill. That's a skill. You're going to want to pay attention when you're in that section. Section 3.4 is systems via inspection. You're just going to be looking at these things like these cases I gave you down here. Where, how do I know they're going to intersect? How do I know they're going to be parallel? How do I know they're going to be the same line? Well, these two in particular, if it's the same line or parallel, they will have the same slope. What's another name for slope? Rate of change. They will have the same rate of change. If they have the same rate of change, you know it's either going to be parallel or the same line. And that's what you'll be talking about or figuring out, spending time with in section 3.4. And then 3.5, I've already told you there's only one way to solve systems of inequalities. What is it? I just mentioned it in passing. It's not like it's by graphing. The only way you can do systems of inequalities is by graphing. So what I just told you there is you have to use Desmos. You have to use Desmos. And we already know that Desmos, wow, that was easy, wasn't it? We need a Staples easy button. So there you are. That's Unit 3, the entire chapter in a nutshell. Woohoo! Well, I can take the next 2 weeks off, right? Yeah, no. All right.